If you're in the AI space, you've likely heard of AI voice agents and the value they can bring to businesses by automating inbound and outbound phone calls. While these AI voice agents may seem pretty straightforward to build, the process actually involves 5 essential steps. And by the end of this video, you will learn all 5 of these steps needed to create the perfect AI voice agent. Now, step 1 is choosing the right transcription and speech models. We'll start off first with transcription. What we need is accuracy, cost, and speed. Now, luckily, there is a website called Artificial Analysis, which has a leaderboard that ranks all these different speech-to-text AI models or transcription models. It has different rankings like the word error rate, the speed factor, and the price. And obviously we want the culmination of the 3. Word error rate showing a higher accuracy. So the higher this is, the worse, and the lower, the better, because obviously we don't want errors. Then we have speed factor. We obviously want the speed to be high as we want to be transcribing real-time conversations. And therefore for that, we have Whisper Large V3 as the quickest. And that is the same as the second place, again being Whisper Large V3, but it's just different providers. So this one is on Fowl.ai and this one is on Grok. Then we have the pricing, which is obviously really important. And in this chart, it's showing you the price per 1,000 minutes of audio. And for the Amazon Transcribe, as you can see, the highest price, we have 24, that being $24. And for Whisper Large V3, we have 0.5. So as you can see, we have extremely high speed, extremely low price, we have the lowest price and the highest speed, and we have the third lowest error rate, which makes Whisper Large V3 the best transcription model by far at the moment. However, unfortunately, the platform I use for building these AI voice agents, Vappy, and I do use an experiment with other platforms as well, only allows for DeepGram, TalkScriber, and Gladia, with these 2 not even being in the analysis because they're not good enough. I've also tried to reach out to the different AI voice infrastructure platforms out there, which are needed to create these perfect AI voice agents. And in order to create an agent in general, I was unable to find out which transcriber they use. And what I do like about Vappy is that if in the future they do add support for Whisper V3, then we will be able to just change that and instantly improve our AI voice agents. Okay, the second part is the speech models, which again is extremely important because this is obviously what is actually creating the speech of these AI voice agents. So the transcription takes basically what I would be saying on a call and then turns that into the input for the model. Then the model outputs whatever text it outputs. Then that text is used to generate speech based off that output. So what we are looking for is realism, cost, and speed. Now, what I mean by speed isn't the speech speed, so how quick the model is speaking. Instead, I mean the speech synthesis speed. So what is the latency from the generated text from the LLM model to the actual speech being relayed back to the person on the other phone? Unfortunately, that artificial analysis website doesn't do any sort of leaderboards when it comes to text to speech. So I just did a really brief analysis on the top 3 text-to-speech models. These are ranked by realism. This is all in my opinion, of course, and is subjective. And in that opinion, I believe 11 Labs is the most realistic sounding. I do believe their voices do sound a little bit scripted, if that makes sense. It doesn't sound like a human in a natural conversation. It sounds kind of like a human talking to a camera like I am now. You know, I wouldn't be emphasizing things as much as I would be to my friends as I am for the camera. Then we have OpenAI, which has a very similar feel to it as 11 Labs, but it is just that tad bit less realistic. And as you can see, it has double the latency. This number right here is the speech synthesis latency. So it takes 400 milliseconds from the text to speech for 11 Labs Turbo V2. And then we have Rhyme AI, which has the least like emotional sounding voices, but they do also sound extremely realistic. And as you can see, has an extremely quick speech synthesis at a much lower price than 11 Labs. So in my personal opinion, Rhyme AI is probably the best text-to-speech provider right now, as all things combined just make the flow of the conversation with these agents so much better due to that quicker latency. If 11 Labs Turbo V2 had a 200 ms speech synthesis time and cost, 6 times less, then it would be, by far the best. However, I do believe Rhyme AI is probably your overall best. So Step number 2 is your LLM model. We just spoke about the transcription model, which takes what the person on the phone is talking about, transcribes that into text, passes that text to step number 2, which is the LLM model. The LLM model then generates a response and sends that to our voice and speech synthesis model. And then that generated speech is then sent back to the phone as audio. And then we can repeat that cycle as a flowing conversation. So for the LLM model, we are looking for quality, cost, and speed. For this, again, we have the website Artificial Analysis that goes over and analyzes the different AI language models, as well as the different API providers in order to find the best one. So as we can see here, quality, which is the reasoning and intelligence of a model, we can see that GPT-4o is 100 and therefore the highest quality model. Coming in second place, very close, is Claude 3.5 Sonnet, which was just released. Then we have Gemini 1.5 Pro and so forth. Then we can move on to speed. Obviously, we want high speed. Again, with the conversation with the AI voice agents, we want them to be able to respond as quick as possible to make those conversations flow better. So as we can see, we have Gemini 1.5 Flash as the highest output tokens per second. So it will output 165 tokens per second. And therefore that reduces the latency needed for a response back to our prospect or to whoever we have on the other line of the phone. Then we have Cloud 3 Haiku, Llama 3 8 billion, Mixtral 8x7b, GPT-4o, Claude 3.5 Sonnet, GPT 3.5 Turbo, etc. Next, we have price. Obviously, if we had all the money in the world, we would just simply use the highest intelligence and the highest speed, whatever best we find. But we want to take price into consideration and obviously try to make it cheaper for ourselves. So taking that all into consideration, we have this kind of quality versus output, which are really the two most important metrics when it comes to these models. But if we look at the graph, we see we don't really have anything that stands out that much. As we can see, GPT-4o is a lot more intelligent than Cloud 3 Haiku and Gemini 1.5 Flash. However, it is that decent bit slower. So this is where you have to make a bit of a decision on your own. Okay, step 3 is the LLM prompt. So when building these AI voice agents, like we have in Vapi right here, we have this initial model and the system prompt of this model. Now this prompt is extremely important, as it is basically the entire brains and instructions of the core AI voice agent. We have a few other things around the AI voice agent, which we will be getting onto in step 4 and 5. However, this is really the main chunk of brains, and we need to make sure that this is perfect. Now, prompting is such a huge topic which has hundreds, if not thousands, of scientific research papers on it, and I can't distill that entire knowledge into one step of a video. So what I've done here is basically put the 4 parts of a prompt that I believe are the most important and which I believe give you the 80% of the results for 20% of the work. And those are role, task, examples, and notes. Now the role is, as you can see in this example right here, you are role. So you are an expert marketer, you are a appointment setter, you are a inbound receptionist, whatever that is for your AI voice agent. That is the first thing you should be doing in the prompt. Next is the task. So you will be responding to prospects and getting them to book an appointment. Then we have examples. So examples are extremely potent and really change the results a lot, as it allows the model to see roughly what the output and results look like from the input. So the way I structure my examples is usually user and assistant, as that is usually how the LLM models are trained. That being user is what we input, or the person on the phone is inputting with their speech. And then the assistant is the output we are getting. And then once that's synthesized, it is then becoming speech. Then we have notes, which is basically once you've got the bulk of your prompt, you add a few little details which you notice in testing this AI voice agent. So you must do X, so you must make sure to get their full name. You must make sure to do this. You must not answer when they are being rude to you, or whatever it is. Like whatever you decide to put in the notes section, you do that there. Or you might add something like you shouldn't do X, or you might add some context like you work in London. So if someone says they're from America, instantly hang up the phone, whatever that is. That's where you put the rest of your context and kind of small little instructions for the LLM. Now, like I said, there are hundreds, if not thousands, of research papers on prompting. And this website right here, Prompt Engineering Guide, under the papers section, has a bunch of the different papers that are really good when it comes to prompting. Obviously, reading all of these would take you years. So you can look at some of the overviews and look at some of the more important ones. So if you just do a quick Google search, most important prompt research or prompt engineering papers, read them and start to really understand how to prompt LLM models for outputs. Also, just a quick tip on prompting. This is the feedback loop you should be doing when it comes to prompting. You should be writing your prompt, testing it with some sort of input, checking the output, and then iterating your prompt based on the output you got from your test. This is the feedback loop that really brings the results when it comes to prompting your main LLM. Okay, step 4 is the knowledge base. Now, the knowledge base is so important as it allows your agents to access tons and tons of context that you don't want to be putting into your main prompt, as that's going to add the cost up. So you want to keep all that context within a knowledge base and simply prompt the AI voice agent to check and query that knowledge base when asked a context specific question. So for example, what time do you guys finish? The agent knows that that is a context specific question and not every business or this or that finishes at the same time. So it will just simply query the context knowledge base right there and ask, okay, what time do we finish, let's say on a Tuesday? And it will retrieve that context, take that into consideration, and then output the result. Now, when it comes to knowledge bases, there are two types of knowledge bases, that being the context knowledge base and the example knowledge base. So the context knowledge base is what I just explained in the example. It needs some sort of context to answer a specific question. It will then query that context knowledge base, which just has a bunch of documents about, let's say, your business, and a bunch of information and context about your business, as the name suggests. Then you have example knowledge bases. Let's say we have an AI voice agent that is a customer service rep, and someone asks it, how do I fix X problem? Now, what it can do is query the example knowledge base and be like, do we have any examples of a real customer service rep answering the question of how do I fix X problem? And then take that example and use that perfected example of what the customer service rep did and use that in our response and just kind of emulate it. So the tips I have when it comes to, better knowledge base retrieval and better outputs for your agent is removing fluff. You don't want to clog up your knowledge base with a bunch of unnecessary things and unnecessary information that your agent never uses. And if you have that fluff, your agent has to use its reasoning and its quality and its thinking to be like, okay, this is literally not useful at all, and I've retrieved it. Let me ignore that part. Let's use this part only. Imagine how much easier it would be if you only gave it good things and it's like, okay, this is perfect. Let's go, let's think, and let's output our answer. Another tip is increasing chunks. Now, chunks is the tokens, let's say, of a knowledge base that are being retrieved when querying it. To put it simply, if we increase the chunks, we increase the amount of context we're going to get, which does increase the price as we're obviously inputting more tokens into the model. And the other problem that increasing the chunks is, which is solved by tip 3, is that obviously we're giving a bunch of context to this main LLM model, which we don't want to be doing. And let's say we get 300 paragraphs worth of context for every time we query it. Then what we want to do is take the question, whatever that person said, give it to an AI step and basically be like, look, this is all the context we got. Can you sift through all that rubbish and find the only relevant things about the question? And those are really the only 3 tips I can give when it comes to knowledge bases, as they aren't really rocket science. You just want to put in good quality information and context and examples into knowledge bases, and that's really it. Now, the 5th and final step when it comes to creating the perfect AI voice agent is tools. Now, tools are the things that actually allow the AI voice agent to perform real world actions, like booking in a meeting, like checking someone's delivery time. So the tips when it comes to building tools is use as much non-AI logic as possible. Now, as you can see here, I have this arrow going down to use code if possible, because obviously some people aren't able to code, and you are able to build tools in no-code or low-code automation platforms. I have videos where I build tools on platforms like make.com, which is a no-code automation platform and allows you to build tools. However, code is an asset. If you have all your automations all on one platform like Make.com. If Make.com shuts down and goes bankrupt, what happens then? All your tools are gone. Whereas if your code editor, stops working, let's say, like Microsoft VS Code just blows up and never works again, you will still have all your code on your computer or on the cloud. The next tip is offload as much reasoning as possible from the agent. We give our main LLM model the date today. So we say today is Sunday, 7th of July, and the person we are speaking to says, oh, can I book a meeting, let's say at 4 p.m. on Wednesday? And from that, the agent has to reason, okay, so he is talking about this Wednesday. When it comes to sending this date to the tool, I have to format it as 2024-07-07, as that is 7th of July, and it has to be in that format. And we have to add 3 days because today is Sunday, and we have to add 3 days to make it Wednesday. And all of that reasoning adds time and latency and more chance to error. So we just want the agent, for in that example, just send, I want to book in a meeting at 4 p.m. in natural language like it got from the person on the phone. And we want to give all that reasoning to the tool, as that tool is literally built only around changing natural language of a date, let's say like this Wednesday at 4 p.m. into formatted dates, which basically allows the main LLM model to think as little as possible. Now, the last tip is to use tools in order to retrieve data with webhook responses. So what that means is essentially we can use tools to retrieve different information and data. So let's say we are building a customer support AI voice agent as an example. We want to retrieve, let's say, the order status of an item because the person said, oh, I haven't been told about when my order is coming. Can I know, whether it's being processed? Has it left the warehouse yet? How long is it going to take for the delivery? And then what we do is get the agent to ask, can I get your order ID? And let's say it's 1234567. Then it sends that 1234567 ID to the tool. Then the tool does its logic, gets back from whatever logic it does. The order is processing. It will take 3 days to leave the warehouse, and then it should be around 7 days for delivery. Then we can send that information back to the agent with a webhook response, and then the agent can respond with that context specific data. Okay, so that's the 5 steps to build the perfect AI voice agent. We have the transcription and speech models, the LLM model, the prompt, the knowledge base, and the tools. And only once all 5 of those steps are in synergy do we create a perfect AI voice agent.